Hi everyone. This screencast is about how we sketch periodic functions. So the general form of a periodic function is something like this equation here, y equals a sine bx plus c plus d. Now in this equation, the x and the y are the variables for the horizontal and vertical axis. The a, the b, the c and the d are numbers. We call them parameters. The values of a, b, c and d control the size, shape and location of the resulting graph. So here's an example that I'm going to give. A equals 3, b equals 4, c equals 90 degrees and d equals 1. If I was to sketch this graph, I do a little bit of preparation first. The first step is thinking about b. Now, remembering that in this formula, b equals, sorry, that was supposed to be a 3, equals 360 degrees divided by t, which is the time for one complete wave. Now, I have b, but I really want to know t. T is the horizontal measurement across the graph. So I'll start with calculating t. T equals 360 divided by the value of b, which is 4. In this case, that's 90. Good. I'll start to sketch now. So here comes my x and y axis. So we begin with d. D is the vertical shift. In this case, it's -1. Oh, sorry, it's +1. What am I talking about? So I'll put a little value here of +1, and I'll put a horizontal dotted line. This represents the equilibrium position for my sine wave. Now I'll switch over to the beginning to look at the value of amplitude A. It's +3. That means that the maximum the graph will reach is 3 steps above and 3 steps below for the minimum at -2. The graph will bounce up and down between those limits, centered around that dotted line at +1. The next thing I need to know is t. T is 90, so I'll mark a position over here at 90, which represents a full wave. I'll split that into half. Half of 90 is 45, and then I'll divide each of those again, so I have 4 sections to the graph. It's much easier to do these diagrams in 4 steps. The last thing I need to consider is the value of c. C equals 90 degrees. Now if I go back, c is the phase shift. If I go back to my original sine graph, this is the graph of y equals sine of x, no fancy letters a, b, c, d. Look at where the 90 degree point is on this graph. The 90 degree point on this graph is there at the top of the crest. That tells me that my graph with a phase of 90 degrees will begin from the equivalent part, the top of the crest. Now that I've got that information, I think I'm ready. The top of the crest is here. After 1/4 of a cycle forwards, we'll move to the equilibrium place. After 1/4 of a cycle, we'll be down to the lowest point. 1/4 of a cycle, we're back to equilibrium. A further 1/4, we're back to the very top. And it's a full cycle. It has to be a full cycle because 90 is there. Now I'll do a quick sketch. It's a curved shape. This is a bit rough. There we go. So that's how we use the parameters a, b, c and d to sketch the function. Now I've got here a little GeoGebra that I made. It's a little bit too large at the moment, so let me just bring that on in here. Here it is. Now what I'll do is I'll set the values here in my GeoGebra. A equals, now I've lost control because I changed the size of it, didn't I? There we go. I need to make A equal to 3, B equal to 4, nearly there, C equal to 90, and D equal to +1. Now, if I did a good job on my sketch, my graph down here should look the same. It's a little bit, I'll just expand that out a little bit. we'll be able to see and make a comparison. So it looks like I haven't done too bad a job there, but just leave that sit there. I've gone from maximum at 4 down to minimum at -2, back up to maximum at 4 in a 90 units, 90 steps across the horizontal scale. It seems like my GeoGebra software agrees with my sketch, and that's how you do sketches of periodic functions. Thanks for watching.